homework? How many of you forgot? Okay, you're honest. You're honest. Can't remember everything. So, does that mean that the 20 of you didn't put your hands up, didn't forget? Homework. Gentlemen, homework. Did you have intelligent conversations about nuclear power at home last night? Right, come on. Shh. I will resort to the copy off the board routine if you're not going to listen. I am capable of producing the dullest lessons ever, just about. Here's this page from Wikipedia, copy it out. Right, the thoughts at home then, or the adults you spoke to, did they have strong views? Did they not really care? Did they have? What did you think of their views? Come on, be prepared to speak. Ellen, you've had your hand up. Thank you.
My dad, he visited nuclear power plant recently, and then he was very positive about it. And then he said that it's the best and most efficient way to produce energy. And they're in his opinion, there are no pollutants, and it doesn't produce carbon. I think he said, and it's safe. And he doesn't really see a way in which it could it could go wrong, but he doesn't see it as a negative thing.
Okay, so do you think he was against it before he went to the power plant?
I don't know. I'm not really sure. But it seems that as if he had always supported it because.
Yeah. Okay. So the plant he went to, they did a convincing job of saying, actually this is safe.
Yeah. Exactly.
Where was it? Do you know?
I can ask.
Was it in Finland?
I'm not sure.
Right. Okay.
Yeah.
Yeah.
Well, I asked my brother, and he also said that he was for it, but he does understand that there are a lot of safety issues because the waste that is produced by nuclear plants is radioactive, and there have been many events in the past that have harmed the environment, especially.
Yeah.
And he just thinks that if it's more it is far more efficient than, for example, fossil fuels, and it is easily produced. A lot of energy is easily produced.
Yeah. Okay, so another one in favour. Auntie, I'm sure that wasn't a stretch. I'm sure that was you putting your hand up saying, I want to say something.
And my parents would think it's good because it brings jobs.
Okay, so actually we've got 3 in favour. Any against? Yeah.
I didn't ask why.
Okay, but just a no.
Yeah.
Yeah, okay. Really interesting because there is definitely a generation thing going on as well. And also probably the economy as well. The jobs in the area are very, very important. Yeah, okay. You've got to make up your own minds. Probably on the election calculator, election machine that you get. Did you do that as part of civics? Yeah. Was nuclear power mentioned on that? Having a nuclear reactor. Okay, it has been in previous years. Are you in favour of nuclear power or not? And there was a big argument at one point, 12 years ago or so, I believe, when the Green Party changed their political view, and it used to be that to be a member of the Green Party you had to be against nuclear power, and now the Greens have completely switched around. There is this idea that I was telling you about yesterday, that nuclear energy is sustainable, it is green. By coincidence, I got my monthly magazine from the Institute of Physics come through, and that's a big international organisation where developments in physics are discussed, and there was an article in that about, is nuclear energy actually green? And they said, well, What do you mean by green? Do you mean zero carbon emissions? And I said yesterday, zero carbon emissions for nuclear power, yeah? Well, yes, there are zero carbon emissions when the power plant is running. There are not zero carbon emissions when the power plant is built or when the uranium is extracted. Yeah? But when a nuclear power plant is sat there producing energy next to a coal-fired power station producing loads and loads of carbon dioxide. But in the process of setting it up, in the process of setting up wind turbines, in the process of setting up solar panels, you have not got zero carbon emissions. So zero carbon emission is impossible to get. Then there's things like other particles that are emitted. Coal burning emits a lot of environmental carbon and other particulates. Nuclear power, well, it doesn't until it goes wrong. And then there would be a lot of particles. Is it sustainable? Are we going to have the fuel forever? Is uranium, the nuclear fuel, is it actually renewable? No, it's not in theory, but we're not going to run out of it because so little fuel is actually used. So it is a big, big hot potato issue. So yesterday we started talking about nuclear, the nuclear reaction, didn't we? Notes are optional. You can take notes if you want. Asking questions and talking to me is compulsory. Please, I want to encourage you to say what you think and ask questions. Okay, so nuclear energy, I'm just going to kind of brainstorm it a bit. Nuclear energy comes from the nucleus, protons and neutrons, yeah, and there are two types. There is nuclear fusion and there is nuclear fission. Yeah, fusio and fissio, I think, in Finnish. Now, nuclear fusion is absolutely wonderful. It's what powers the stars. And it is where you have protons colliding together and releasing energy. This is amazing. If we could recreate fusion on Earth, we could solve the global energy crisis. The trouble is, to recreate it on Earth takes more energy at the moment than we get out of it. You can't just build a sun on Earth because it takes too much energy to do so. Nature does it spectacularly out in space, but we can't do it. Okay, so this is a problem. It takes too much energy. It's really sad because it doesn't produce any nasty, horrible radioactive stuff. And if we could crack fusion, then we could have lots more people on the planet. We wouldn't be wrecking it because of carbon dioxide and stuff like that. So maybe it's a good thing if we don't crack fusion. I don't know. Okay, takes too much energy, but you will hear it being discussed. There's lots of scientists working on ways making fusion energy productive and economically viable. So we are left with fission, and this is where you have got large nuclei, large atoms split to release energy, and they actually produce radioactive waste. That's the problem with it. Okay, so in a nuclear reactor, in a power station, it's basically a controlled bomb. We talked about that chain reaction yesterday. Okay. We do not want the bomb to ever get out of control. So far to date, and I hope this is true forever, there have only been 2 nuclear bombs released in war. Hiroshima and Nagasaki. Okay. Those nuclear explosions were much, much bigger than any accident that has happened in a nuclear power station. No nuclear power station has ever catastrophically blown up in a way that a bomb has. The explosions that have happened, and the 2 really famous ones, Chernobyl and Fukushima, were not reactor meltdowns. They both could have been a lot worse. That is what is actually scary. No nuclear reactor core has actually ever blown up. The nuclear reactor blowing up is like a nuclear bomb. And given the destruction that was caused by both of those accidents, that's pretty scary. The world so far, touch wood, I hope it never does, has not seen the worst possible nuclear accident from nuclear power. I hope it never does. Yeah. Elna.
I'm not sure if you answered it already, but like, how does a nuclear power station like blow up? Like, what is it that goes wrong?
When we look, I haven't answered it already. I'm going to show you a video of how the nuclear power station works, and then we can talk about where the weaknesses are.
Okay.
Yeah, because Chernobyl was human error. Fukushima was natural disaster, possibly with human bad design responsible. Yeah. Neither of them was a deliberate destruction, because that's sadly the other option as well. Okay, so should we have a look at? We'll have a look at a video. This video, I'm sure, is produced by some lovely company that is responsible for educating the public, yes, or producing nuclear reactors. ENEC Education. And advertising videos. Bless you.
Nuclear energy facilities generate carbon-free electricity in 30 countries around the world. Nuclear energy production is similar to the ways fossil-fueled power plants generate electricity. A nuclear energy facility provides clean, safe electricity 24 hours a day. Let's go inside the plant to find out how. In most generating plants, whether coal, nuclear, or natural gas, some form of energy is used to heat water into steam. This steam turns a turbine that is coupled to an electromagnet called a generator. The generator produces electricity. While the model is the same, there is a key difference between nuclear energy facilities and other electricity generating plants. Power plants that run on fossil fuels burn coal, oil, or natural gas to generate the heat that creates steam. In a nuclear energy facility, a chain reaction of splitting atoms releases heat. This reaction takes place in the reactor. All reactors are designed, built, and operated with safety as a top priority. Nuclear energy facilities are among the safest facilities in the world because they feature multiple redundant layers of safety systems and procedures, beginning in the core of the reactor. In a nuclear reactor, metal rods with enriched uranium pellets inside are placed into bundles, creating a fuel assembly. The bundles are submerged in water inside a pressurized vessel. The 2 most common types of nuclear reactors are boiling water reactors and pressurized water reactors. In a boiling water reactor, the heat from split atoms causes the water to boil, producing steam that drives a turbine. Afterwards, the steam is converted back to liquid water and returned to the reactor core. Pressurized water reactors, or PWRs, were developed after boiling water reactors and work in a slightly different manner. In a PWR, the water in the reactor tank is under pressure to keep it from boiling, even though it reaches very high temperatures. In the steam generator of a PWR, water passes through thousands of small pipes. The heat in the pipes turns the water to steam, which then drives the turbine. The turbine powers the generator, which in turn produces electricity. Here is where the process differs from a boiling water reactor. The reactor water is now pumped back into the reactor tank and heated again. The steam from the turbine is cooled in a condenser, and the resulting water is sent back into the steam generator and heated again. To prevent overheating, control rods made of a material that absorbs small atomic particles are inserted into the nuclear fuel bundle. When an operator wants to produce more heat, the control rods are raised out of the bundle. To create less heat, they are lowered into the bundle. The rods can also be lowered completely to shut the reactor down in the case of an accident or to refuel the facility. With this level of control, the operator of a nuclear energy facility is able to ensure that it continues to generate clean, safe, and secure energy. Additional safety systems are in place that shut the reactor down quickly and stop the fission process, cool the reactor down and carry heat away from it, and create barriers to contain any radioactivity and prevent it from escaping into the environment. Nuclear energy facilities are the most efficient source of electricity in the world. By developing a nuclear energy program, the UAE is leading the way for other nations that may look to generate clean, safe electricity in the future. Nuclear energy for the UAE, part of a bright future for our people.
Okay. And there are similar advertising videos all over the place for different countries. And when I was teaching back in Bristol, the only place we could ever get a free trip to take a class to was the local nuclear reactor, and they gave us biscuits, they gave us free buses, and things like that. Everybody else, where else we had to pay for, because they were desperate to persuade everybody that it was safe. And then 9/11 and the terrorist attacks occurred, and all the visits were stopped. Okay. Any questions before I go on to talk a bit more about the structure of the nuclear reactor? No questions? Right. Okay. The one that would be built near here is a pressurized water reactor. Okay, let's steal that picture. It's good enough. On. Thank you. So this is the basics of a nuclear reactor. Okay, they've missed it. Right. The nuclear fuel is in the red rods here. Is it better to actually have less light on? You okay sitting in the dark?
Yeah.
Yeah, it means I look at you less and I can't see if you're using your phones. My bad. Okay, so in the red pipes there are the nuclear fuel pellets, and the pellets, they look about the size and shape of marker pen tops, like these. Okay, and that's the uranium-235, and they're actually really, really heavy. These rods are maybe 2 meters long, but their weight, because their mass, because uranium is very, very dense, is going to be, I don't know, something like 20 kilos, something like that. So they are packed into tubes with little gaps in between. So that would be the rod, they're the fuel pellets. And they are dropped in from the top of the nuclear reactor. Okay, and they can be lifted out as well. So you've got the nuclear fuel, and then you have got in between them, you've got these green rods, which are the control rods, the neutron captures. captures. And if you remember from yesterday, you'd have one nucleus splitting up with it. You'd have a neutron fired in. This would split up, and then you'd get three more, and then very, very quickly it would go what is called critical, and at the critical point it's going to go uncontrolled and the reactor's going to blow up, and that has not happened. Hopefully never ever happens. It's happened twice deliberately in nuclear bombs in war. It's happened thousands of times probably deliberately in nuclear tests. There are nuclear tests going on across the planet all the time by the nuclear powers. So any country that's got nuclear weapons, like, can I remember them all? USA, so Russia, UK, Israel, China, India, Pakistan, North Korea. Japan refuses for pretty obvious reasons because of Hiroshima and Nagasaki. Then there's all sorts of stuff about should other countries be allowed to have this technology. Iran, Iraq, and it's been on the news a lot. Okay, because all you need is the fuel and a good internet connection, and you can find out how to build a nuclear bomb. In fact, you can look this up. This isn't fake news. There was one guy in Sweden who was very interested in making his own nuclear reactor, and he nearly did it. He actually bought lots of things for a nuclear reactor, and he produced in his backyard, in his shed, a really dangerous situation that they had to come around with radiation shields or whatever. You can build, if you, this is why the internet's such a very dangerous thing, that if you want to play around and build stuff, then the knowledge is there, get the supplies. He actually used, there's something that you can get on old-fashioned camping gas stoves that produces radioactivity, and he was using those thorium mantles. So this is why some people think that you young people shouldn't be allowed on the internet, because you could learn how to build bombs. But isn't it better to learn how to understand about building bombs and why to build bombs and why not to build bombs? Isn't that better? I don't know. Anyway. So the neutron catchers, control rods, these are great big long tubes, just like the fuel rods, and they can be raised and lifted out of the reactor. So if you've got, say, new fuel rods, fresh fuel in with lots of uranium, you'd have the control rods right down so that they are absorbing, they are taking away many of these neutrons, so you control the speed of the reaction. If the nuclear fuel is a little bit older and less neutrons are being produced, then you raise them a little bit. If you decide to raise them all at the same time, so you don't catch any neutrons, then your reactor goes critical. This is what happened, or it gets towards critical. This is what happened in Chernobyl. Now, I grew up spelling it like that. How's it spelled in Finnish? Is it like that? You know where I mean, don't you? You've not heard of it. Really? Okie dokie. It was well before your lifetime. 1986. In a part of the Soviet Union, now the Ukraine, there was a nuclear accident. In the town, or near the town of Chernobyl, there were, I think, 4 nuclear reactors. and they were part of the old Soviet nuclear power program. They were maybe not the safest reactor designs in the world because they were still being basically human controlled. They had computers, but they had a human override in them. And the technicians who were working one of the reactors were performing a test with the control rods. And they could manually control how much the control rods were lifted out. And they got a calculation wrong. They left the control rods out for too long. And they didn't leave them out, they just left them raised for too long. And what that meant was that there were too many nuclear reactions going on in the reactor. So the water, the coolant that was going round, got superheated to a high pressure. The pressure inside here was too much, and it popped the radiation protector barrier, and the building around it, because these are usually encased in large buildings. The rods were only out for a tiny fraction of a second, that they were immediately dropped back down again. But in the meantime, the reactor had overheated. So there was too much heat being produced. The top of the reactor exploded, not because of a nuclear meltdown, but simply because there was so much steam and heat energy being produced. It was a gas explosion. It wasn't the reactor core. And then that gas went out into the atmosphere. Only it didn't just kind of go above the reactor. It exploded out so fast and furiously, it went into the upper atmosphere. Okay. 3 days later, or was it 2 days later, the radiation sensors in Northern Europe were saying, or the radiation detectors were saying, we've got a bit of a problem. Hello, USSR. Have you had an accident? No, we've not had an accident. Nothing going wrong here. And this story was maintained. Apparently, the Finnish detectors detected it first, but it was some public holiday in Finland, so the Finns didn't bother about it, allegedly. That was the official excuse. It was probably not very polite for the Finns to be ringing up the Russians and saying, hey, yeah, that looks more like it. We think one of your reactors might have exploded. It was the Swedes that did that instead. And actually, at that point, the Russian authorities admitted there was a problem. And by then, they'd already evacuated the region and were trying to stop it from going critical and huge problems. But the radiation cloud, this is just part of where it went. Some of it went south. It all depends on where the wind currents were in the atmosphere at the time. Some of it swept up here. Some of it went over the UK. That was quite a few days later. Yeah, these were the areas it covered. Yes, Brigitte.
You said they tried to stop it from going critical, but like, how do they stop it?
Is it time to show you a really depressing video?
Yeah.
Sure.
Yes.
Okay, what they shut down the reactor, so it wasn't online to produce any more nuclear energy. The problem was the uranium and the fuel rods were all still in the reactor, and they were therefore decaying radioactively, and it wasn't going to take long before it literally would go critical. You can't just turn the power switch off on a nuclear power station and walk away from it. If you do, within a few days, it's going to go critical. So they had to get the fuel out. Okay. The liquidators. Actually, no, that's not the one
So some people went in there and then like took them out and then they like got killed in the process or
Yeah.
like.
This is this is depressing. Actually, that's the right. Sorry, this is the wrong one. Let me. Never rely on a Google search. I wasn't going to show you this today, but we're on the subject. No, it's not that one. Sorry. It's a silent video. Any comments? Yeah.
My parents grew up in the Soviet Union, and I'm not sure exactly what people did, but I know my parents knew people who worked in Chernobyl and they passed away.
Yeah. It's, yeah. It's tragic. It's tragic for the people who were around that area. That's why no one wants a nuclear power station in their backyard, pretty much. It's awful. Yeah.
But in one part of the video, they poured something like on the reactor.
Yeah.
And then it said that that only increased the risk of it blowing up or something.
The sand and.
Yeah, so
Yeah.
why did they do that?
Because they didn't know.
So they
Such a possibility had never really been thought about. Again,
they think that dropping that sand
Yeah.
would help.
yeah, they knew you have to get the control rods out. So first of all, electronic devices, robotic devices, radio-controlled devices, the same is true today, were sent on top of the reactor. Their circuits got fried within seconds. So the bio-robots came along. And the bio-robots, well, they did a deal with lots of prisoners in the USSR. Hey, how would you like to be free for the rest of your life? We will stop your prison sentence. Yeah, okay. You just got to do a little job for us. Go on top of that nuclear reactor, pull these rods out, run very fast, and drop them over the edge. Most of the biorobots were prisoners. And it was true, they were free for the rest of their lives. Their lives were maybe 5 days long. They died horrible cancerous deaths. There were people in Fukushima who also voluntarily sacrificed themselves to do similar sorts of jobs because they knew that that was important, and otherwise there would be massive devastation around Fukushima. So this is not just the old Soviet Union. Yes, there are certain things you can pour into reactor cores that will help, but basically what they had to do was remove the control rods as much as they could and then contain it. And now the reactor, the first thing that they did was they actually literally put a huge great layer of concrete over the reactor vessel. Nuclear reactions are still going on in the core of that, and radiation is still coming out. And in fact, the concrete began to crumble within about 30 years. And then another concrete is called the sarcophagus. The sarcophagus is what you put over a dead body. And the concrete sarcophagus, they keep maintaining it by building more and more on top of it. Not because it's going to blow up and go critical again, but because what's inside is producing so much radioactivity that it is affecting the materials around it. So let's have a 3-minute stretch break and we'll talk a bit more about it. Just look at how the mood in the room has changed as well. That film does it. It's a different sort of film style to the first film style you saw. The happy, oh, it's safe advertising video. Couldn't get 2 more different contrasts. Go stretch, preferably without thumb stretching.
I didn't know it was like that. I knew it was something like that.
Wait, so you said that like they have to keep putting the concrete sarcophagus.
Yeah.
So people have to keep sacrificing themselves.
No. Now it's at a level where you're not having to walk right over the top of the reactor. It is still dangerous.
Yeah.
There are very, very big strict restrictions on who can go into that area.
Yeah.
You can have a tourist trip near the area.
Yeah.
There are actually tourist trips to show
Children.
tourist trips to that area. Nobody's meant to be living within a certain radius,
Yeah.
but every so often workers get to go in and you can have a certain dose that is calculated and very, very carefully controlled. They say, okay, you can work this close to it for a certain number of hours per year, and you should be safe.
Yeah.
Yeah, and you'd have to sign and say, yeah, it's okay.
Yeah.
So if you're a really high cancer risk, then you probably wouldn't want to take that job.
Would they pay you a lot of money?
They should.
Yeah.
It's the Ukraine, so I don't know whether it's actually the Ukrainian authorities that do it, or whether it's a global atomic energy authority that does it. Because politics then got in the way. The Soviet Union broke down. The Ukraine was left with this really nasty environmental problem and an expensive mess.
Yeah.
And they couldn't finance it. And they actually said, what do we do? We've got all these nuclear reactors that used to produce a lot of energy for the Soviet Union. They're all in Ukraine, not a very highly populated area.
Yeah.
We can't be responsible for this. So in fact, a lot of the nuclear program got shut down and amended there. And I'm not sure how much money the government puts into it and how much internationally is put into it. Because it's all the former Soviet Union's fault in a way. But usually then there's big collaborations, government collaborations that we place for it. And then they're paid to the workers as well, I guess. don't know, part of me horrifyingly thinks maybe they get immigrants to work because they'll work for cheaper wages.
No, it kind of grossed me out that they're speaking like how safe it was, like to use these nuclear energy sources, and then all of a sudden they had to watch like a really sad video of people who are working there who got instantly.
Yeah, that's partly why I wasn't going to show it today, but it does just show the contrast. Nuclear power splits people. You're either really, really against it, or it's okay, you're in favour of it.
No.
And now, now everybody's completely the other way around. Yeah. It is, it's controversial. Controversial. And we are going to be in 100 miles away from the nuclear reactor. And probably wherever you were in the US, you were quite close to the nuclear reactor. You may be in
Virginia?
Probably.
Maybe. Here, Washington.
Yeah, you would have been. Okay, come on back. Oh, you 30 seconds to stretch. No, you don't.
We'll talk about it. I will have if I was
Can we watch a video of like what happens when a nuclear bomb hits the ground? Like, I feel like we saw it in one, so like a history lesson.
Yeah.
Something like that. Yeah. Is it the same kind of thing?
Yeah, it would be. Yeah. I guess I'll think about it. Yeah.
Siis ei, mä en missään nimessä halua ainakaan käy silleen, että ne olisi pitänyt tehdä ja sitten me ei ole.
Yes. What you've got is the gas has been stripped of all the electrons on the outside of the ions. Right.
And it's not like up to
I'd rather maybe next week. Some yeah. What would have happened if that had been a nuclear bomb and the whole reactor had just blown up? Well, actually, it would have been over and done with very, very quickly at that point. There would have been a huge great crater and hole in the ground, but and there would have been environmental damage. It would have killed a lot of people. There'd have been a lot of deaths afterwards. But Hiroshima and Nagasaki are both cities where people are living. They're very successful cities in Japan. Life does come back. The problem with a nuclear power plant is that that the reactor isn't completely blown up. In some ways, it might have been better if it had been. There isn't this history then of 1986 it happens, and the area, nobody's going to be safe to live within, I think, 100 kilometers of that area for thousands and thousands of years. And that's partly, well, yeah, when the atomic bomb went off, it went off above the ground, etc. Different conditions, but dead nuclear reactors or dying nuclear reactors are very, very, very dangerous. Even ones that you want to close down safely, you've got to be extremely careful how you take the control rods out and where you put the stuff. You are going to get homework again today. Yeah, go on.
How does it like continue to generate like or give out the nuclear energy? Doesn't it mean that like actually?
Well, the uranium fuel pellets have got enough uranium in them to go on for a very, very long time. You never completely get rid of all the uranium that's in them, but when they decay within that pellet, their daughter nuclei are also radioactive, and then they decay, and then they have more decay products, and this goes on and on and on. And whenever there's a radioactive decay, you get some heat being given out as well. Yeah.
How does it like stop like
you said that like they can't live like anywhere close to it for thousands of years. So like, how did it stop? And when do you know that it's not? There's no more radiation.
Put very crudely and very simply, you don't end up dying of cancer if you live near it. It's as simple as that. Now, there are massive studies going on at the moment about the animals that are living near there. There's some really good wildlife documentaries going on because the humans have moved out. It's now become a nature haven. But there are quite a lot of illnesses amongst the animals and mutations amongst the animals. And I was reading a report of incidences of childhood illnesses within like 200 kilometers of that area, and something crazy like 87% of all children have respiratory problems, bad asthma, cancers, etc. It's absolutely frightening. People go in with radiation detectors that give off all the clicks when there's radiation around, and when those detectors are at a low enough level, then people can move back into the area again. Undoubtedly in Hiroshima and Nagasaki there is a legacy of radiation damage, incidences of cancers that are caused by the bombs that went off there as well. There is within the whole atmosphere from weapons testing. 30 years ago, I think 30, maybe even 40 years ago, when the Cold War ended, there was an agreement to stop above ground nuclear weapons testing. Nuclear weapons are now tested below ground. Above ground is really dangerous because the fallout gets into the atmosphere and it spreads around the whole planet. We are all getting doses of radiation from that, but it's absolutely tiny compared to natural radiation that we get, and you couldn't say that because of the nuclear weapons tests that somebody died of cancer, because statistically we just can't match that. If you, whereas in the 60s, if you were in the military and you were right next to bombs that were going off for military tests, then you could maybe argue it. So there's the whole really difficult statistic risk thing to take into account as well.
But how do you
go on? Yeah.
How do you know, like, if the daughter nuclei like keep like multiplying and like splitting, like how does it stop? I guess.
Eventually, all atoms they decay and they all end up as lead. So on the periodic table, that's just like a thing that takes billions and billions and billions of years. Part of it is a natural process. You would only know if you could compare the levels in the soil, in the plants, in the animal bones, with ordinary levels in similar areas. That's the only way that you would know. I mean, for instance, just by where you live, you can tell from analysis of bone whereabouts you grew up, etc., because of the minerals that are present. And some of these might be more radioactive than others. We are living in a more radioactive country on average in the world than other countries because of the rocks. We've got very, very old rocks, and certainly up in Lapland. So they are, because they were closer to the center of the Earth, they actually have more of the radiation from the Earth. Also, we are living at a more northerly latitude. We're closer to the North Pole. We have more northern lights, so more radiation from space comes and affects us. We get about, is it 2.5 times the dose of background radiation compared to the UK? I've done it because I've done the calculation many, many times. Doesn't mean that I'm 2.5 times more likely to die of cancer. It's really complicated. Does that answer the question?
Kind of.
Kind of.
Yeah.
Right. Homework for you lot tonight. I know we're nowhere near the end of the lesson. Your parents, 1986. How old are your parents? This is where I'm going to feel really old. 40s?
Yeah, 38.
38. I feel really, really old. 38. So they were born in
78 and 79.
Right, so they will remember it. Ask them what they recall about the Chernobyl disaster. If they were, well, it doesn't matter if they weren't in Finland, but ask them what they recall and their grandparents. What happened? Anything happen in this area? Okay, we can talk about that next time. That is quite an interesting discussion. Did any of you, when you talked to your parents or whoever about the nuclear power station, did they mention Russia at all?
Well, because my dad was like saying that everyone is afraid of the nuclear power plant because of Chernobyl. But then my dad was like, the technology was quite old because it's 30 years old by now. So then like these technologies have been like improving since, because technologies like as it improved like at a steady rate.
Yeah.
It went like going up
Yeah.
that way. So he was like, now the reactors and all of the equipment that they use are way safer. So I think that, so he thinks that nuclear power plants are very good for countries that doesn't have like natural or like, you know, like solar or.
Yeah. Yeah. So he mentioned Russia because of Chernobyl. Yeah. Marie?
Well, my dad also thinks that the nuclear power plant will like get more Russians into Finland, and he doesn't think that's necessarily a bad thing because, like, for instance, it's going to be better for us if, like, you know, there are more language options and stuff like that available.
Yeah.
Which aren't just Finnish, but also my parents definitely felt the effects of like Chernobyl when it happened. They think that Finland would be able to manage it much better than the Soviet Union did.
Yes, definitely. The Russia and the Soviet Union are very, very different beasts. However, as probably many of you realise the moment you mentioned that Rosatom, the company that's going to build the power station is Russian, then how to say this without sounding really racist and xenophobic, any Finns who are older than about 50 years start getting really worried about it because of the Russian thing. Yeah, so it is a sensitive issue. Or you could call it racism or whatever you want to call it. But yes, the technology has changed massively. No longer can a bunch of technicians sitting Homer Simpson-like behind a control panel say, hey, let's test the control rods. Okay, there are computer overrides all the way around. You can't have one nutter controlling it, or one person who doesn't know their physics controlling it. Yeah. There are international inspections all the time in nuclear power stations as well. There is a non-political organization that is in control of nuclear power that I don't think the Trump administration can touch, or Putin's administration, or Le Pen's administration if she gets to be president. So that was Chernobyl. What about Fukushima, the Japanese? Technologically brilliant. What happened in Fukushima? Do you know? Do you remember? Have you heard of Fukushima? Yeah?
When was that? Like, what was the year?
March the 11th, 2011. So, there were many nuclear power stations on this site because it was right by the sea. There were 6 nuclear reactors. What went wrong? What caused it? Do you remember what caused it?
The earthquake.
Yeah, earthquake which caused a tidal wave, a tsunami, natural disaster. So basically, these got flooded. And when they got flooded, water, the classic, water and electricity don't mix. So the generators that were pumping the water around the nuclear reactor to cool it down, this cold coolant, those generators stopped. And I can remember, this is where it is so different today compared to Chernobyl. Chernobyl got found out 3 days later. I was watching these nuclear power plants live on TV when one of them started to have smoke coming out of it, because there was a tsunami. It was a devastating tsunami, and then the news was saying, uh-oh, there's some nuclear power plants in that. What's going to happen? And the scientists were desperately trying to get the generators restarted to get the coolant pumped around. Yeah.
Why would they build it like near water?
Because you've got to cool the nuclear power plants down with something, and you need a reliable, constant, cheap supply of water.
Okay, so they didn't really predict that this kind of thing would happen.
No. They should have had better walls,
Yeah.
but when you had the tsunami that they had there, there was you're powerless. This is an act of nature. Nothing really, I think, could have stopped that. So you've got to be careful where you build your power plants. I wonder if someone's done a Google map on it. Excellent. The internet's amazing, isn't it? Only it hasn't got them all on there. World location. Come on, why are you disappearing off? They're the European ones. That's on a river or a lake. Yeah. The US ones would be good to find. Okay, it's not showing them on a different scale. Around the lakes, there you go, Virginia.
Really?
Nuclear power plants there, etc., etc. What's not, yeah, it's not showing is the ones that are all along the west coast, along the San Andreas Fault. Okay, you do not want to build your nuclear power plants in a seismically active region where you've got earthquakes. There you start looking at a risk assessment. Okay, if there is an accident, it's probably going to kill lots and lots of people. So it is high danger, but there is a low chance of danger. After all, you only get one huge earthquake along the San Andreas Fault every 100 years or so. When was the last one? Oh, 100 years ago. Okay. Japan doesn't get drowned by many tsunamis, but when it does happen, it's very, very highly dangerous. Whereas you take something like coal, power station, there's an ongoing low level of danger all the time. If it's low level and it's medium risk. So over time, that adds up to an awful lot of people dying from respiratory problems, things like that. So you hear about Fukushima and you hear about Chernobyl killing lots of people and being very, very, very destructive because they are big one-at-a-time accidents. But what you don't hear about, well, it's beginning to be talked about, are the number of deaths every year because of burning fossil fuels, because of carbon particulates. I heard one figure that 10,000 people a year are dying in the UK because of that. Now, if 10,000 people died because of a nuclear accident, then nuclear powers would be stopped in the UK. But nobody's going to stop carbon, coal burning, etc., etc. Okay. Any questions about Fukushima? So you don't build nuclear power stations in seismically active regions. The Japanese government immediately shut down its whole nuclear program, and all the reactors are being decommissioned. Okay. And then we have one more problem that I hope will never happen, but could be the cause of the third nuclear disaster: terrorist threat. This, I've got to admit, this is the one that worries me the most. Let's have a look at what some nuclear power stations look like. Let's see what was it? Calvert Cliffs Nuclear Power Station. Annika, have you ever heard of it? Calvert Cliffs Nuclear Power Station. It's the one in Virginia. Really? Yeah, there it is.
No.
Okay.
Maryland.
Is it? Oh, sorry, it's Maryland. Sorry. Okay. So that's what it looks like. Let's have a look at what is it? Oki. Loviisa. I can remember Loviisa. The Loviisa power plant. It's beautiful. They're the nuclear reactors. Look at that lovely location. Yeah. Now, unfortunately, in those big towers, the majority of which is concrete reinforced with steel, so the walls are about, and I'm not lying, half the thickness of this room. Solid concrete with steel wires around it, yeah? So that is the protection from the reactor blowing up. It doesn't work, it wouldn't work, it's not thick enough. It's like trying to stop a Molotov cocktail or a petrol bomb with a piece of tissue paper. But it's got some protection. Okay, and very often it will protect against the coolant pipes popping, but not completely, like in Chernobyl, but very, very thick. Is that enough to stop an aeroplane being flown into it? 9/11 style. That's the terrorist threat. The terrorist threat isn't about terrorists infiltrating the workforce and doing something to the nuclear power plant, because there are so many computer checks. Now, I'm not talking about Finland here, because I'm not really sure why any terrorists would want to fly an aeroplane into a Finnish nuclear reactor, because Finland hasn't upset anybody as far as I know. Okay, not even Sweden are going to get that upset if we beat them at ice hockey again. But in the USA, it is a very real threat. So there are big no-fly zones around lots of nuclear power stations. They're on the radar as places that have to be very, very heavily protected. So I've really cheered you up now, haven't I? I don't think anybody's going to fly near Owl with a flying to a nuclear reactor. There wouldn't be any point actually, because globally, I'm not just saying this to make you feel better. I'm saying this as a physicist, right? When you look at the world map, even though it's probably not an accurate one by area. Come on, view image. Access forbidden to a world map. Thank you. Let's find another one. Okay. When you look at the air currents within the world, yeah, you've got the Arctic air currents with the weather here. Remember, have I ever showed you the air pressure map? And this whole area, yeah, that's one flow area. So radioactive gas would be covering this sort of area. If a power station blew up, it wouldn't necessarily get to Poles because the way the global air currents circulate because of the sea currents here. So if there's a big explosion here, it tends to circulate around the Arctic. If a terrorist view is to try to kill as many people as possible, you'd choose something that's a little bit more in the equatorial areas. Okay, that's thinking logically, she says. Any questions, any comments? How many of you are in favour of nuclear power now? No. Ella, go on, you are.
I'm not really sure because if there's a risk, then that's like the only bad thing about it. I think like if something bad does happen, because like over time when looking at like other like power stations, they're gonna make the same or they could make the same damage like over time as a nuclear power station could make in like a couple seconds. That's
Yeah.
possible.
Yeah.
Yeah. So I don't really know.
I think it's something we would all happily live without.
Yeah.
We are all risk takers. You know, statistically, the safest form of transport is flying. Are you a nervous flyer? Flying is the safest form of transport because so many people do it and there are so few accidents. The trouble is, when there's an accident, it's absolutely horrifying. And you hear about it because it's in the news because lots of people have died at once. Yeah, probably.
Actually, like, I'm more scared of landing. So that
it's so
they don't have tires, or if they don't have the light is broken and they don't have you seen the movie? There's a movie where the light bulb is broken, but what they were actually trying to do wasn't broken, so they thought the wheels weren't.
Yeah. I'm one of these air crash investigate junkies as well. Yeah, the 60-cent light bulb on the switch panel wasn't working, and they weren't sure it wasn't working, and it led to X, Y, and Z happening, and then the plane crashed. Yes.
That scares me.
Yeah, of course it does. I'm sorry, but even though I know the physics, the thought of being 11 kilometers up in the air and not touching solid ground, it does worry me. It petrifies me. But I love flying. I'd hang my head out the window if I could, because it's just amazing. Yeah. If I flew every day, I might be more worried. I drive the car every day. Me behind the wheel of the car, far more dangerous than anybody flying an aeroplane. And that's true for most of us.
Once I'm in the air, I'm fine, but landing and going up is scary.
You've got the choice of doing high risk or moderate risk activities like drinking alcohol, smoking, stuff like that. We still do it, even though it puts us in danger. And if you're not thinking of drugs like that, then taking in sugar, caffeine, cannabis. And then they start arguing about what the risks are because people are telling you it's not good, and there are no easy answers. Nuclear energy, if there is an accident, it's really, really, really bad. But there actually have only been very few accidents, but they've been majorly high profile. And I suppose with nuclear energy, the accident doesn't just go away after a while. It remains, it hangs around. That would be a big problem if nobody could go to Honey Kiddie for thousands of years. That site there. If we'd have known about climate change happening, assuming we believe in it, would we have gone ahead with it, with all these coal-fired power stations or not? Would the human race have carried on with it, or would we just said, oh, it doesn't matter because it only is going to affect things in 10 generations' time? Now you're the generation it's affecting. I know. Okay. Shall we get back to some traditional physics? Yeah, okay. Why does it give out lots of energy? I've told you the process. The most famous equation in physics is E equals mc squared. It's because of that. Yeah. What does it mean? Energy. Energy is equal to mass times
The sun's
speed of light squared. Einstein's equation, it's a simplification of something, but it linked these seemingly unrelated concepts together. Like the speed of light, what has that got to do with anything? Well, it's meant to be a very, very important number. It is a very important number in physics. It's the speed that you cannot get to if you have a mass. You can only travel at it if you have no mass, like your light, microwaves, radio waves. It is 3 × 10⁹ meters per second. You are familiar and happy with standard form, aren't you? Yeah. Okay. It's like a big cosmic speed limit. And it's this value that Einstein just kind of decided you can't get any higher than, like I can't be accelerated that high. It would take more energy than there is in the universe to accelerate an electron to that speed. It can get very, very close, but not at that speed. Now there's a connection that if you've got a mass like the mass of, I weighed myself this morning, bad, 92 kilos, putting on too much weight again. Okay, 92 kilos. If I could suffer a complete annihilation of myself, if I went nuclear, if I went critical, and I just disappeared, this is how much energy I would produce. So what is that? That's 92 × 9, which is 18, 82 times 10 to the 18. So that would be 8 × 10 to the 20 joules. 8 with 20 zeros after it, joules. If you can completely destroy a mass and turn it into energy, that's what you would get. Luckily, that doesn't happen because that's a huge amount of energy. So when does it happen? Because we don't notice that. You can't just suddenly destroy something so that they disappear in a flash of gamma radiation. By the way, if that did happen, then I'd probably nuke the whole of Finland. Yeah, it would not be good. Okay, what happens is that on a very, very tiny scale, mass and energy interchange. This happens basically inside the atom, inside the atomic nucleus. And in uranium-235, there are 92 protons and there are 143 neutrons. And added together, their mass is less than the separate mass of each proton and neutron. It has become energy. How much energy? That's where E equals mc squared comes in. So, this is a really important concept. If I have 6 little Lego bricks, 7 little Lego bricks, okay, and each one of those, the red ones are neutrons and the brown ones are protons. I can weigh these and they weigh exactly the same. And you'd expect all these neutrons to weigh the same, all these protons to weigh the same. When you stick them together to make something like the nucleus of an atom, you would expect that because they are still protons and neutrons, and I haven't cut them open to do anything like that, they're all just arranged together, you'd expect that to weigh the same as 4 neutrons plus 3 protons. They don't. 1,000th of their mass has disappeared. 1,000th of their mass has actually been converted into the energy that sticks them together. Now, 1,000th of their mass in a uranium atom is 4 times 10 to the minus 30 kilos. So 0.290 kilograms in one uranium atom. It's tiny. When that uranium atom's nucleus gets split, that amount of energy is released. And that's where the energy comes from in a nuclear reactor. And Einstein realized this really weird thing, that when you get the little bits all separate, their mass is more than when they're all together. And that mass deficit has become energy. How much energy has it become? Well, in a uranium atom, if it's 4 times 10 to the minus 30, then you multiply that by the speed of light squared and you get the amount of energy. And it's a tiny, tiny amount of energy. It's 0.1901 joule or so. It's absolutely tiny. But then if you've got lots of uranium atoms together, and you can get them to split all at the same time, you produce loads and loads of energy. But it's a tiny, tiny, tiny proportion. And you don't even see it. The proton doesn't look any different when it's together in the nucleus than when it's separate. So it's like saying, you just stick them together and 1,000th of the mass is gone. but they're still the same. It's weird. Any questions? Yeah.
Why do they use uranium? Like,
because it's got loads of this, what's called this mass deficit energy that's easily available. So other nuclei, other heavy nuclei, they're either difficult to get hold of or they are not going to produce as much energy per nuclear decay. This is the most convenient, uranium-235. Actually, uranium-238 does produce more, but they tend to use that in weapons and it's harder to get hold of. Economic and physics reasons. Okay? Yes. Right. Now I need to look up nuclear bomb the physics of a nuclear bomb explosion. Okay, see what I can do. Okay, thank you very much.